Welcome back to the channel. This is the Earth Science Classroom. This video is on rocks and petrology, and we're going to look at chemical weathering, what this is, and define the word chemical in terms of breaking down of rock, and look at different types of chemical weathering as well. This is the Earth Science Classroom. In this video, we're looking at rocks and petrology and looking at the three types of rocks: igneous, metamorphic, and sedimentary, and how they are affected and weathered chemically in nature within the elements on the surface of the Earth. So weathering is the natural breakdown of rocks through different means, either mechanically or physically, or in this case, in this video, chemically. Now, the word chemical means acids. So the addition of acids to a rock, which will break down the rock into smaller and smaller pieces called sediments. Now, this could also be in solution based on the type of chemical weathering, but the addition of acids are going to change the chemical composition and the reactions within the minerals, which then make up the certain kind of rock. Now, in more ways, we're looking at sedimentary rock because of the composition of these rocks and the mineral arrangement, and also the formation of sedimentary rocks allows for chemical weathering to act upon these kinds of rocks more so than, let's say, igneous or metamorphic. So sedimentary rocks will be the focus of this chemical weathering video. As mentioned before, sedimentary rocks are more susceptible to chemical weathering than other rocks based on the mineral and atom arrangement, the composition, and also generally the strength of the rock. Now, sedimentary rocks, when exposed to chemical weathering on the surface and the addition of acids from either the atmosphere, the terrestrial or lithospheric realm, which is the soils, and also through any kind of water and biological acids, will act upon these rocks and produce chemical weathering at a certain rate. Now, the rate or speed of chemical reactions in which these rocks undergo when the addition of acids occur in nature is dependent on the climate, the temperature, and the precipitation, and the amount of rainfall, the amount of biological activity, which can have an effect on the amount of time that the acids are acted upon the rock and the speed of chemical weathering of that rock, and also the surface area of that rock. And lastly, the mineral and element composition. So some elements are more susceptible to breaking down chemically when exposed to acid. And surface area plays a vital role because the more or the increased amount of exposed surface of that rock will also increase the rate or speed at which this rock is chemically weathered and broken down. So the more rock is exposed and touching the acids in the environment, the rock would naturally break down quicker, again, based on the factors that control the speed of chemical weathering. So if all these factors are in place, climate, mineral composition, time, and biological activity, the more rock is exposed to this, the faster this rock is going to break down chemically into sediments. When discussing chemical weathering, we first have to discuss the role of hydrogen ions in a solution, which would affect the acidity of that solution, the pH. Now, when that acidic solution with increased free hydrogen ions is interacting with a rock, especially a sedimentary rock, but also igneous and metamorphic, it'll have a reaction, a chemical reaction, by either adding or subtracting within the chemical formula and causing chemical bonds to be broken and reorganized within that rock, within the minerals and the atomic structure. So the molecular structure is changing, and this can change the hardness of the mineral in question, and certain elements and minerals are more resistant or weaker to this acidic solution, this chemical weathering. Now, in addition to surface area, which would either decrease or increase the rate or speed of chemical weathering, a main environmental factor is climate and the presence of water and heat. Increased amounts or volumes of water and heat within that environment is going to increase the speed of chemical weathering, such as carbonation and oxidation in the presence of air. Now, certain minerals are more susceptible to chemical weathering than others. Minerals such as calcite, CaCO3, is generally weaker, and the chemical bonds between the elements are generally going to break quicker when exposed to acidic solutions compared to other minerals like quartz that have a stronger bond. Minerals like feldspars and ferromagnesian minerals, which include more iron and magnesium, they are going to be more susceptible and weaker to the hydrogen ions in solution in terms of breaking the chemical bonds and releasing ions such as sodium, potassium, more iron, and more magnesium. Minerals like olivine and pyroxenes and amphiboles are also less resistant and weaker when exposed to chemical weathering on a certain rock. And a very common byproduct of this chemical weathering and the change in molecular structure of the elements is to form clays. Now, going back to surface area, if you have a single cube-shaped rock with 6 sides and you're going to slowly chemically weather and break down that single cube, that volume of rock, be it igneous, sedimentary, or metamorphic, if it breaks into 4 smaller separate cubes, you now have 24 sides that are now exposed to any chemical weathering, which goes for as well mechanical and physical weathering. But with more exposed sides and surface area of that rock, the rate or speed of chemical weathering is going to increase because there's more surface in which the acids can react with within the rock and the mineral and obviously the elements. So we've discussed what chemical weathering is. It's the addition of acids within the environment which are going to chemically act upon and react with the rock, mostly sedimentary, but it does have an effect on both igneous and metamorphic. But it's going to break down the rock and have a reaction with the mineral composition based on certain factors in the environment, and eventually break down and rearrange the bonds and break the bonds within the rock into smaller sediments or even solution. Now, this happens through various types of chemical weathering, such as carbonation, biological, oxidation, hydrolysis, and dissolution. Now, the first, carbonation, is with the addition of carbonic acid, H2CO3, when you have CO2 and H2O chemically reacting in the atmosphere or even in water sources, and you get the production of a weak acid which will act upon the rock, change the chemistry. This can happen in the soils, and what you get if it acts upon a area of sedimentary rock, it will produce what's called a karst environment, which means that it will change the rock and produce cavities and voids and form in a certain environment called karst, which includes caves and caverns and sinkholes. Then we have biological chemical weathering, which is the acids in the soil and the detritus and humus and organic material having that acid component which would act upon the rock, again within the top layer of the soil, which is the O and A horizon, which has the majority or concentration of that organic material. Then we have oxidation, which is the addition of oxygen, O2, which exposed to elements like iron, it will turn to oxidation and rust and the corrosion of these metals with the addition of oxygen. Then we have dissolution, which means that the ions and the salts like sodium chloride are going to basically dissolve within a solution. So chemical reactions will allow the solid material to basically break down enough that it becomes a solution within, let's say, water, and that would be carried away, which is erosion, the transportation of weathered material from place to place. And then we have things like deposition and different environments, but the dissolution is the process of taking a solid and dissolving it into a solution. Then this is able to be transported easier through gravity and through various erosional agents, through water sources. Then we have hydrolysis, again involving water, which is closely linked to carbonation, biological, and also dissolution. The addition of hydrogen ions and hydroxyl ions, looking at the pH of the water, looking at breaking down minerals in terms of the clay minerals in feldspars, looking at creating joints and fractures within, let's say, granite, which is an intrusive igneous rock, and breaking the bonds within the minerals using water and using the polarity of both the hydrogen ion and hydroxyl ion to chemically react with these sedimentary rocks mostly. This is the Earth Science Classroom. Thanks for watching the video. If you liked it, please subscribe, like, and share. And if you want more content and videos on Earth Science, please check out my channel.